So this is a video on the uses of ultrasound, and the first thing to do is to establish what we mean by ultrasound. We have sound, which we can hear, and we can hear a range of frequencies from 20 Hertz to 20 kilohertz. We have infrasound, where the frequency is too low for us to hear, so it is below 20 Hertz. And we have ultrasound, where the frequency is above the top end of what we can hear, above 20 kilohertz. So ultrasound is sound with a frequency greater than 20 kilohertz. So there's a bass guitar which has a frequency of 20 hertz in this particular example, and a dog whistle greater than 20 kilohertz. We can't hear that. One of the uses of ultrasound, one of the uses you're most likely to know, is ultrasound scanning. The ultrasound is introduced into the abdomen using a probe, which is kind of just off screen here. And the probe sends the ultrasound waves in. Whenever the waves, any wave, not just ultrasound, encounters a difference of density, when it goes from the probe into the abdomen, when it goes from the abdomen into the uterus, when it goes from the uterus into the fluid, when it goes from the fluid into the flesh of the fetus, when it goes from there into the cartilage or the bone or the brain, there is a change of density, and you get a reflection at every one of those changes of density. Those reflections then are used to build up the picture. Echo sounding out at sea, the Royal Navy would use ultrasound, which they would call sonar, to find submarines, for example. So the machinery knows, the sonar equipment knows that sound travels at about 1500 meters per second in water. So it times how long it takes from when the pulse is emitted to when the reflection is received. And based on that time and the speed of sound in water, it works out how far away this thing is, because it's traveled twice the distance to it in that time. That factor of 2 is an important consideration in any calculations you will do on this. The time from emission to receipt of the reflection will be twice the time it takes to get from emission to the object it reflects off. So it's used to find submarines, it's used to find shoals of fish for trawlers, it's used to make sure the ship doesn't run aground by checking the depth of the sea. So very useful. You can use it to detect cracks in solid objects if you're a manufacturer of critical steel components, things that are used in building or in machinery. You need to check that there are no air pockets, air bubbles, or cracks in the thing that you've made inside where you can't see them. And so you have your ultrasound transducer. You can move it along the surface of your beam or whatever it is. And as the ultrasound goes into it, you'll get a reflection. As the ultrasound meets the other side and comes out, you'll get a reflection. And so you have this regular series of reflections as you move your transducer along, but you get to here and you get an earlier reflection. So you'll get a reflection here, you get a reflection here, you'll get a reflection on the other side of the crack, and you get a reflection here. So immediately you know that you have some imperfection in here. You can check the size of it and you can understand the scale of the issue you have. Kidney stones then. Drinking lemon tea without drinking lots of water can lead to a buildup of mineral deposits in the kidneys, forming kidney stones, and these are very painful. They need to be got rid of. So by firing ultrasound at them, you can cause a kidney stone to shatter, and whilst you wouldn't have been able to pass out the whole kidney stone in your urine, you can pass out the small pieces. So this is a non-invasive medical procedure. There's no surgery involved, which obviously reduces risk and reduces recovery time. So that's all good. And my final use of ultrasound for you is in cleaning delicate machinery, really. Mechanical watches, if you take your Rolex in for a service, then the watchmaker will strip your Rolex down to its component parts. It will be suspended in some cleaning fluid, and ultrasound will be passed through the cleaning fluid to clean those parts before the watch is reassembled. You can't just take a brush to it because they're so delicate you destroy them. And also the same thing is done with jewelry if it's very delicate, but also because there are nooks and crannies in the jewelry perhaps that you can't reach very easily, and so doing it like this in the cleaning fluid with ultrasound gives you a much cleaner job, much better job, and much less labor intensive.